Welcome back, and let's continue with our lesson. So now, the picture below forms a pattern with the number of lines. Continue the pattern for the next two pictures. So let's look at the pictures that we have here below. So we are looking at the number of lines. The first picture has 4 lines. That is 1, 2, 3, and 4, right? So the next picture, with the 4 that we already had, now we have 5, 6, and 7. And the next picture has 10 lines as shown in this table below. So we need to continue for the next two pictures. Now, how many squares are we going to have in the next picture? So we have here 3 squares, and then the next picture is going to have 4 squares. But we are looking at the number of lines. So let's count how many lines we have here. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So in the next part here, it says represent the pattern in the table below. It means for the 4th picture, we are going to have 13 lines. And then in the next picture, how many lines are we going to have? Already between these 4, we had 13 lines. And then we added this last one, which now will give us 14, 15, and 16. So now we have 16 lines for the 5th picture. But what will be now the algebraic equation for this pattern? Because if we are asked again for big numbers, we cannot go continuing drawing so many lines. That is just going to waste our time. So we need to find an algebraic equation so that we can find the bigger numbers, or how many lines are in more pictures, So let's look at the table below represented here. Again, in the first picture, we had 4 lines. Now we need to find the relationship between the picture and the number of lines. So it's actually the same as finding the relationship between the term number and the term itself. Let's look at the difference between, or the number of lines that we are always adding to get to the next picture. So from 4, we are adding 3 lines. And from 7, we are adding 3 lines. And from 10, we are adding 3 lines. Why am I looking for this number? Remember, the constant difference is the one that is the first one that we look at when we are looking for our equation. So we are going to say that our Tn is equals to, that is my constant difference, multiplied by my term number, or in this case, the picture. And we need to find something to add or subtract so that we can find the first term. So let's look at the first term, which is going to be 3 multiplied by 1. And then we know that 3 multiplied by 1 gives us 3. But now what can I add or subtract to get to 4? So 3 plus 1 will give me 4. And that is my first term. Let's check if this plus 1 stays the same for, let's now take maybe the 3rd term. So if I say the 3rd term, and I say 3 multiplied by 3, because we are working with the 3rd term, so 3 multiplied by 3 is 9. And then when we look at the actual 3rd term, that is 10. So from 9, how can I get to 10? Yes, you are correct. I'm going to plus 1, and that is going to give me the 10. So what does this mean? It means that my Tn will be my 3 multiplied by my n. And what do I do every time to get to the term number? We are just going to add 1. So it means that my nth term there, or my algebraic equation, is 3n minus 1. If I want the 20th term, what am I going to do? Oh, sorry, that is a plus 1. When I want the 20th term, what am I going to do there? I am going to say 3 multiplied by 20, that's 60. And then when we add 1, that gives us a 61. What about the 50th term? That's going to be 3 multiplied by 50. And then when we add 1, that is going to give us 151. And then when we say 3 multiplied by 200, that is 600. And when we add 1, that is going to give us 601. So that is the algebraic equation for that pattern. Let's move on to the next point of our lesson, the last point of our lesson, and that is solving for problems in the context of number patterns. So let's determine the algebraic equations for the following patterns, and then we are going to calculate the 25th term. We have here 1, 4, and 7. First, what do we need to do? Yes, find the constant difference. So, remember how we find the constant difference? We are going to say the second term minus the first term. So 4 minus 1, that is a 3. It means we are adding 3 from 1 to 4. What is 7 minus 4? Again, it is a 3, a positive 3. So that means we are adding from 4 to 7. We are adding 3. So what is our what is our algebraic equation going to look like? So remember, for our algebraic equation, we are going to say 3 multiplied by the term number. So that is 3 multiplied by, let me just write the term numbers there so that we don't get confused, multiplied by that first term. So 3 multiplied by 1, we know that 3 multiplied by 1 is 3. But now, how do I go back to my term number, which is the 1? We know that from 3, for us to get to 1, we need to subtract 2, and that will give us a 1. We're just quickly going to check if it's going to be the same for the second term. 3 multiplied by 2, that is 6. But from 6, I need to get to 4. And how do I get to 4 from 6? That is a minus 2. So it means that what we are adding or subtracting here to our general formula or our algebraic equation is a minus 2. And that means that is actually our equation, which is Tn is equals to 3n minus 2. From this equation, we need to find the 25th term. So if I say term 25, I am going to take the 3, I'm going to use brackets so that it doesn't confuse me, and I'm going to multiply it by 25 and subtract 2. So our answer there is going to be, what is 3 times 25? That is 75. And then when we subtract 2, that is going to give us 73. Okay, let's look at in the next example where we are going to be looking at our pattern decreasing, or where we are subtracting a constant value. So now we have 25, 21, 17. So let's look at the constant difference. Do you remember how to find the constant difference? We are going to say 21 minus 25. And I hope from calculations of integers, you can remember how we do this. So 21 minus 25 will give us a minus 4. And when we say 17 minus 21, again, we are subtracting 4. So how are we going to find our algebraic equation? Remember Tn. We are going to take our constant difference, which is a negative 4. We are going to multiply it by our term number, which we represent with the letter n. And now we need to find what to add or subtract so that we can get to the first term. So let's look at our first term here. So our first term is 25. And we are going to say negative 4 multiplied by 1, which gives us a negative 4. But now remember, we need to get to 25, which is our first term. So from negative 4, how much must we add or subtract to get to 25? Do you have the answer? If you have adding 29, then you are absolutely correct. Let's check with the second term if it will still be the same. So we are going to say negative 4, and we are going to multiply this. We are going to multiply this by 2 because we are now looking at the second term, and then we need to get to 21. Again, what is negative 4 multiplied by 2? that is a negative 8. And how are we going to get to 21? Correct? We are going to add 29. So it means that our general formula, our algebraic equation, is going to be negative 4 multiplied by n, and we are going to add 29. And that is going to be our algebraic equation. And if we need to find the 25th term, we are going to use the same equation. And that is going to be now our 25th term. That's going to be negative 4. And I'm going to use brackets for the 25, and I'm going to add the 29. Now, what is negative 4 multiplied by 25? Yes, you are correct. It is negative 100. And when we add 29 to that, do you know what the answer is going to be? Yes, you are correct. It is going to be negative 71. Okay. Let's wrap up our lesson by looking at the following algebraic equation. And then we are going to first find the first 3 terms here, and then we are going to find the 30th term. So now we've been given the algebraic equation, and then we need to find the pattern. So the first term here is going to be, we are going to say 3 minus 5 multiplied by 1, because we are dealing with the first term. So 3 minus 5, that is going to give us a negative 2. For the second term, we are going to say 3 minus 10, because 5 multiplied by 2 is 10. That is going to give us a negative 7. And for the third term, we are going to say 3 minus 15, because 5 multiplied by 3 is 15. And then we are going to have here a negative 12. What about the 30th term? Let's use our equation to calculate the 30th term. So we are now going to say 3 minus 150. And this is because 5 multiplied by 30 is 150. So what is 3 minus 150? If you have negative 147, you are absolutely correct. So if you had the answers to all these questions, well done to you. You did great today. That is it for today's lesson. I hope you enjoyed it as much as I did, and then we'll see you next time. Goodbye.